tortilla chips, right? Nacho cheese flavored triangular tortilla chips.
I was at the store yesterday and I swore I heard someone say tortilla chips.
Ooh, yeah.
And I was so
Someone was trying to get under your skin for sure.
confused.
All right, let's pick up where we left off. We'll come back to this one. I know you've already done this one, but in the sequence of doing the notes, I'm going to jump over here to D. Okay, and then we'll come back and do your E. Remember what were the instructions for this one? We're doing example 11D. The instructions were to was it to prove? Do we have to prove that? Well, we're gonna come back and do E. Y'all did E for the warm up. I'm gonna do D first and then get to E. I have to warm up before I warm up. Now this one here, some equations you don't have to solve algebraically. Some of them you could just solve by what's it called? Insight, clever intuition. We're looking for the angle x where sine equals cosine between 0 and 2 pi. For what angle do the sine and cosine ratios equal each other? I'll just go ahead and start by writing x equals, and y'all can just throw out the answer. Where do sine and cosine equal each other on the unit circle? That would be their ratios are exactly the same. Pi fourths, good, because at pi fourths, they're both square root of 2 over 2. Excellent, excellent. Anywhere else? 5 pi fourths. At 5 pi fourths, they're both negative square root of 2 over 2. Very good. That's the answer. Those are the two solutions. Nicely done. Now, what if you didn't use clever insight and intuition? What if you're just like, I'm a robot. When I see stuff, I do stuff, right? You could get everything. What? One of the things we learned yesterday was to talk loud so I can hear everything. I hate missing a good joke. Okay. All right, all right. That's why I tune myself out when I talk, because none of them are good either. Yeah. Yeah. Okay. We learned yesterday that if you have more than one variable term, and here we have two, the strategy is to get everything on one side and set it equal to 0. So we could do that. And once it's equal to 0, right, your goal is to factor it. Do we have any common factors there? No, we don't, other than 1 and negative 1. Can we write sine in terms of cosine or cosine in terms of sine very easily? Which identity? Baby pid? Well, anytime you say pids or Peppa Pig, you should be thinking squared, right? And neither one of those are squared, so we can't use the pids there. Now, the only identity we have that relates sine to cosine without being squared is the tangent, right? Tangent of x is sine over cosine. So if you want to solve that for sine, you get cosine times tangent. Do you want to go ahead and do that? Yeah, but at least it would give me a common factor, wouldn't it? Let's try it. You know, we're walking down that alley. We see people at the end. We don't know if they're thugs or if they're a dance troupe yet. We need to take a couple of more steps. So sine is cosine of x times tangent of x minus cosine of x. Okay, that equals 0. Now we can factor out a cosine. So that gives us tangent of x minus 1 equals 0. So now we can break it into two smaller pieces. So cosine of x equals 0, or tangent of x minus 1 equals 0. All right, so now we're ready to solve this. Where does cosine equal 0? Pi halves and 3 pi halves. And tangent x minus 1, that's where tangent of x equals 1. Where does tangent equal 1? Well, that's at pi fourths and 5 pi fourths. So, what the heck happened? We picked up the two solutions that we got intuitively, but we also picked up those fellas. Any explanation or possible reason why? Do they work? Let's see, if you plug, let's try it. If you plug in a pi halves, sine of pi halves is 1. Cosine of pi halves is 0. That one doesn't work. Try 3 pi halves. Sine of 3 pi halves is -1. Cosine of 3 pi halves is 0. Well, that doesn't quite work either. So what happened here? Those are extraneous solutions. We can still pick up extraneous solutions. That's one of the side effects of doing substitutions, because remember, each identity is only going to be the same over its domain. So when we replace something like sine and cosine, whose domain is all real numbers, with something like tangent that has domain restrictions, there is the possibility of picking up some extraneous solutions. Just like when we square both sides, remember, that's another red flag for extraneous solutions. So when in doubt, you should just try your answer choices out. Now let's do that another way. That's not the only way to do that one. Does anyone think of another way? Well, maybe not. Here's another strategy. Before we get everything on one side, let's go ahead and square both sides. Does that work? Yeah, in the process of solving, we can do that. Now, why would we want to do that? Well, because y'all already were mentioning at first the PIDs, right? And to use the PIDs, they have to be squared. So let's go ahead and square both sides. But you learned from algebra that when you square both sides, that is a prime case for extraneous solutions. So that raises a red flag. Okay, so we'll be careful. We'll check our solutions. So I get sine squared of x equals cosine squared of x. And now I could bring everything on one side. It's easier to square it before we bring everything across. And now I get sine squared minus cosine squared. Is that Papa Pid right there? Oh, no. To be Papa Pid, they both have to be positive. If they were both positive, it would be positive 1. If they were both negative, it would be -1. But when one's positive, one's negative, that's not Papa Pid. But here's what we can do. We can replace sine squared with what? Using Papa Pid. 1 minus cosine squared. Yeah, that's probably worth just saying over and over in your head. Sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. Minus cosine squared. Now, I just replaced the first one because it was easier. You could have just as, maybe not just as easily, but you could have replaced cosine squared with 1 minus sine squared. The reason I chose not to is because there's a negative there, and I would have to distribute. So I was like, ugh, let's not. So now I get what? 1 minus 2 cosine squared. I get like terms. And now because I'm down to a single variable term, now it's time to isolate it. So bring this across, and you get 1 equals 2 cosine squared. Divide through, and you get cosine squared is equal to 1/2. And now we'll take plus or minus. So when you do that, you get cosine squared, or we take the square root. Cosine of x equals plus or minus 1 over the square root of 2, which is equal to, of course, the square root of 2 over 2. And now we're ready for the unit circle. Where does cosine equal either positive or negative square root of 2 over 2? Well, it's at all the pi fourths angles, right? Pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. Are they all solutions? Maybe. Good answer. Survey says, nah. When we try them out, we have to try them back out in the beginning, meaning not the squared version. If you plug in a 3 pi fourths before you square it, sine of 3 pi fourths is positive square root of 2 over 2, but cosine of 3 pi fourths is negative square root of 2 over 2. Those are not the same. You have to plug them back into the original equation. And so we do get that to be untrue, and of course that one's also going to make them opposite signs. So we do have the extraneous solutions, and either way we end up with the same answer. So Three different ways to solve that. The intuitive way is very quick, very direct. The other two algebraic methods with substitutions, check for extraneous solutions. Okay? All right, any other comments or questions on that one? All right. Bless you. That problem was lit like Notre Dame Cathedral. What? Oh, okay. Sorry. Yeah. All right. Yeah. Good. 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 A lot of different ways to do it. Yeah. Very, very sad. Very, very sad. There's already two very wealthy families that have pledged like $300 million to help rebuild it. You know, can you believe that? It's like, oh, we'll rebuild it. I'll pledge $300 million. I'd be like, I'll send you a nickel, okay, in an envelope if you pay for the stamp. You know, good luck. Yeah. I'll draw you a picture of a rose window you could tape up until you get the new one in. Okay. Yeah. Never forget or whatever. Hashtag. All right. Let's try this. This is one you warmed up with. Hey, I spy a cosine on both sides. Should we divide both sides by cosine? I'm not even done yet. If we did that, we'd get that. That'd be awesome. No, you can't do that. Because when you get rid of a variable from both sides, you lose possible solutions, and you don't want to do that. So that would be the wrong way to do it, okay? Like replacing the rose window with a drawing of mine. That would be the wrong way to replace it. What should we do instead? We have two terms. Yeah, get on the same side. 2 cosine squared of x minus cosine of x equals nothing. Now we will divide out the cosine, but we're not going to get rid of it. We're going to bring it right out front. Cosine of x now is equal to 2 cosine of x minus 1. And now we could set both equal to 0. So cosine x equals 0. Or when you set this one equal to 0, this is an honors class, right? Formerly a pre-AP class. I don't know if that upgraded or downgraded y'all, but yeah, whatever. You could set that equal to 0 in your head and solve for cosine of x at the same time, right? That's cosine x equals what? 1/2, positive 1/2. So if you want to do that, that's awesome. I trust y'all to do that. And now, guess what time it is, everybody? It's everyone's favorite time. It is unit circle time. Right. Right. It's also 9:15, which if it were 4:15 instead of 9:15, that would be the date that the Notre Dame Cathedral burned down. Yeah. Which was also tax day. And that's just, taxes were due yesterday. And that's just a coincidence. With Easter this Sunday and the cathedral burning down, someone suspected arson, but the conspiracy theorists, they're going to just blab their mouths. I think it happened when, yeah, there was construction going on. And you know, you've been in a cathedral before or a church. You know, they have the little section with the candles where you can put a nickel in and light a candle for a loved one. Maybe that's what happened too, and someone just, you know, lit it too fiercely, or maybe someone was vaping around the corner and the vape just got out of control. Yeah. I think when they rebuild it, they're going to put no vaping right inside. That'd be a good idea. I'll send them that idea with my nickel. Hey. Yeah. It's sacrilegious. The only thing you could really burn in there besides candles is incense, right? Yeah. Okay. Cosine of x equals 0. Where? Pi halves and 3 pi halves. Good. And then cosine of x equals positive 1/2 at pi thirds. Y'all are getting good at this, and 5 pi thirds, right? We have to be to the right of the y-axis, so quadrants 1 and 4. Now, because we're a little gun shy now, that's probably not a really good term to use. Everything is so taboo these days. We raised a blue flag here. We have learned behavior. The previous two examples, we came across extraneous solutions. So maybe we're apprehensive, or we have now built in a natural distrust, and we want to question everything, right? Do these things actually work? Should we plug them back in and try, or you just want to be like, I hope they work, I'm going to go for it and walk away? Let's plug them in. Let's just try one. Plug it in, make the room smell fresh. Okay, let's try it. We'll plug it. We'll plug in the pi halves. Okay. So what's cosine of pi halves? 0. What's 0 squared? 0. What's 0 times 2? 0. So that's the left side. And then on the right, what's cosine of pi halves? 0. Does 0 equal 0? Yeah. Welcome to the club, pi halves. Well, is it going to be any different when we plug in 3 pi halves? No, it's going to be the same, so it's also going to work. So the pi halves brothers are in. Holy moly. Why does it do that? Apparently not. Okay. Now let's try the pi thirds, okay? What's cosine of pi thirds? A half, right? What's a half squared? A fourth. What's a fourth times 2? A half. So that is a half. And what's cosine of pi thirds? A half. Yeah. So this one's going to work. Should 5 pi thirds work as well then? Yes. So all 4 of them work. Yay. We have enough people now for a quiz bowl team. We have 4 people. Okay. Man, okay.
Were you there yesterday?
I was there.
Oh, no, you weren't.
I was at the quiz bowl and at the powder puff bowl. I was all over the place. They weren't at the same time. The quiz bowl was right after school, and I'll tell you what, man, I had my choice of seats at both events.
You didn't ask for both?
No, I'm just saying that so the turnout was poor. Is what I'm saying. I think New Braunfels could do better. I think students should participate more, right? Instead of just like, oh, it's after school, I'm going home.
I
went to the powder puff.
Good, yeah, good. Right? It's school pride. When I was a student here, man, we went to everything after school. But truth be told, we did not have iPads and stuff like that, where we just buried our face in the screen. Yeah. These are like real events where you actually like go somewhere physically and like interact with people and breathe the same rare air that they are.
Like face to face.
Yeah, faced base. That rhymes. That could catch on. Is that a real thing? Faced base. That could compete with like Facebook. But instead of an online app, it's like where you just go to meet people. Reality. IRL. IRL. Yeah. Yeah, IRL. Spring Fling is IRL. I think I'm going to use that today on the announcements. Hey guys, Spring Fling. It's a face-based activity. It's IRL. Let's get out there and represent. What?
Announcements tiring? I feel like you have to say so much.
I do have to say so much, and I have to say it really fast. And then I asked my daughter yesterday, did you hear the announcements yesterday? She goes, nobody in my class listens. And I'm like, I know, but did you listen? I couldn't hear. Everyone was talking. I was like, crap. And I jumped on like right after the moment of silence. So like, I'm trying to like capture that lull before y'all start talking. Hey, blah, blah, blah. It was like, nah, the moment of silence is over. Let's start talking. Really? Holy moly, smokers! Do I need to shout into the announcements? To make it loud. I mean, I don't know. Can you turn up the volume? Golly. So anyway, all right. Extra credit though for writing 3 math a paragraph for how you decorate. All right, let's look at number F. You're gonna like this one. We have more than one variable term. So when that's the case, we usually get everything on one side. So let's go ahead and do that. 2 plus 2 cosine of x. Red rover, let sine squared come over. Okay, so now it's minus sine squared. By the way, if there would have been a tiebreaker yesterday in the freshman junior game, I thought the tiebreaker was a thumb war. It was actually a red rover game.
What is red rover?
Yeah, red rover. You don't know?
No idea.
You hold hands. The juniors stand shoulder to shoulder, holding hands, locking arms, and the freshman would be on the other side. And then y'all would pick somebody who you think is weak, and you'd say, red rover, let flimsy man come over. And then that person would leave, break arm, and they would run towards y'all, and they would try to run through your arms and break it. Yeah, and if you break their arms, then those people are out, and it's like last man standing. If they don't break the arms, they become part of your team, or they're out or something. Yeah. So that would have been the tiebreaker. It's kind of like a shootout in soccer.
Okay, but the freshmen have so many girls.
I was like,
No, but I would have convinced them. They wanted to do college style from the 25.
that's what I was thinking.
Yeah, but I would have convinced them to do Red Rover. That would have been a lot more fun, wouldn't it? Okay.
What is the soccer?
Oh, it's just a shootout, right? We have the shootout. Everyone takes a shot on the goal. You never seen that? When it's a tie? Yeah, they have a shootout. Hockey does the same thing. Okay. Hey, we have everything on one side. Now we look for a common factor. Do we have one? We do not. Okay. But notice what we do have. We have a squared term, a non-squared term, and a constant. So it might be a factorable trinomial. But there's a problem. These two are not the same. Okay? If I can make them the same, then it might turn into a factorable trinomial. Should I try to turn cosine into a sine? Is that easy to do? No, not without introducing a tangent. We already saw that. But turning a sine squared into a cosine squared is muy fácil. Okay? So, there's a minus in front of there. You see that? Put parentheses before you replace. Okay? Parentheses are your best friends in this math class. So now I'm going to replace sine squared with what? Good. See, we're getting used to that. That's the most common substitution with the PIDs. 1 minus sine squared or 1 minus cosine squared. Okay, now we're just going to distribute this little negative fella, and we get 2 plus 2 cosine of x, and then we get minus 1 plus cosine squared equals 0. And now all we have to do is combine like terms, and I think we'll write it in descending order. So I got a cosine squared in the front. I've got a plus 2 cosine of x in the middle. And now I've got these two guys joining forces. 2 minus 1 makes it plus 1. Yeah. All right, so now it's looking prim and proper, right? So this should factor, and notice the leading coefficient is positive. As I mentioned yesterday, if that had been a negative, and it might sometimes, just multiply everything through by a -1. Change all the signs, okay? So this should factor into the product of two binomials, just like x squared plus 2x plus 1 would. So the square root of cosine squared is cosine, so one of these has to be a cosine. And now we're just looking for factors of 1 that add up to 2. Factors of 1 that add up to 2. 5 and 7? Oh, yeah, 1 and 1, right? The old college 1 and 1. All right. Hey, those are the same factors, aren't they? So you could set them both equal to 0, or you could just simplify it and say cosine of x plus 1 squared equals 0. Okay. Now if I take the square root of both sides, I get cosine of x plus 1 equals, what's the square root of 0? Is it D and E?
0.
Oh, it's 0. Good. Yeah. That was one of the questions yesterday at the quiz bowl. They had all kinds of questions like chemistry questions. You had to know a lot about Supreme Court cases. There were really odd questions about two literary works, The Mending Wall and The Ghost House. Kind of weird. But a lot of math questions too. Some of them were like, what's 2001 times 699? And there was a guy in the freshman team, and then Skylar Vestal just like, boop, gave the answer right away. And I was like, wow. But then there were like math questions like, what is 1/2 times 1/3? Yeah, come on. What's that, everybody? 1/2 times 1/3. 1/6, yeah. 1/2 plus 1/3 would have been a better question. But this was one of the questions at the quiz bowl yesterday. What is the smallest perfect square? They answered 1, but the correct answer was 0. Yeah. Yeah. So y'all just did that. We said, what's the square root of 0? And y'all said 0. Yeah. Y'all would have gotten that right at the quiz bowl yesterday when the person who answered said 1. And everyone was like, I agree. And then he said, Mr. Bone, just so matter-of-factly, that is incorrect. The correct answer is 0. Yeah. He's like a pro at that. Yeah. Like telling you that you're wrong. I mean, he's like, instead of just saying, wrong, like I would have done to make the game more exciting, he goes, that is incorrect. The correct answer is 0. Wow. Very diplomatic. Very tactful. Okay. All right, so now we're going to solve for cosine. We get cosine of x equals -1. And guess what time it is, boys and girls? Unit circle time. Where is cosine equal to -1? Get you some pie. Yeah, pie. Cherry pie. She's my cherry pie. What? Yeah, that song really is. I mean, it's bad. It's kind of bad. It's objectifying a woman as a cherry pie. Um, people sing along all the time to lyrics and they don't even realize what's happening. She's my cherry pie, objectifying a woman like a pie.
Whoa, don't sing that. Make you start running. Oh,
Right,
yeah,
right.
Weird. The
It is
video,
weird.
the music video.
I've never seen
What song?
I'm just saying, if that song exists, that song can exist.
Yeah, I watched it.
What was the one you're talking about?
Pumped Up Kids.
Pumped Up Kids.
Oh, yeah, that's a horrible song too.
Yeah.
Yeah. It does sound kind of groovy, but yeah, it's about shooting up a school. Yeah.
The music video.
I know all about that because I have to come up with songs for the hallway that not only have no curse words, but they have to be about decent topics, right?
And then This Is America.
Right.
That's a lot of stuff.
Yeah.
Black shoes.
It's really hard. Yeah, it's really hard. But I know, right? Yeah. So anyway, I'll never forget that one pep rally where they played Soldier Boy and everyone was dancing like, are we really playing this in front of the whole school? This is a horrible song. Yeah. And then everyone goes, and Superman that ho! And I was like, I'm leaving. This is horrible. And then everyone's like, that's a great song. That's groovy. Oh, it's horrible. I mean, it's worse than cherry pie. I'll let you look it up on your own. I'll let you look. Go to Urban Dictionary and read about Superman that ho, what that means. That's all I'm going to say. That was played at the pep rally. Somebody needs to be in charge of like, no, we're not playing that. But nobody did, and there were no ramifications afterwards because I think I was the only one in there that was a faculty member that was like, that's naughty, right? Anyway.
We were like trying to think of like songs that would like make it more fun. Because ever since their pep rallies are boring and stupid and they want to go home. And then we asked them like what we want to do better. And then
Music?
like don't do them.
Yeah. You gotta get music that is groovy. But you know what? Case in point, I played that groovy tune this morning. It had no lyrics at all. You're not going to offend anybody. It was just violins playing rock. And then when it was over, or before it was over, someone said, what the heck is that? Is it almost over? And I said, yes. Should we remove it from the playlist? Yes. So there you go.
No.
Yeah? We like controversy, I guess. We like singing about it. I don't know. Anyway, the answer is pie. The answer is pie. The answer is pie. Hey, no, not in this class. I don't even want the screen that has that written on it projected into the air. Do not, no. Turn your screen off. That's going to leave traces of that in the room, like a bad fart. Okay? I don't want you looking that up in my class. No. Do that at home where you have air freshener and incense, right? That's the second time incense has come up today. All right, JoJo. Who sings Cherry Pie? Warrant. Yeah. All right. All right. Any questions on the rapid fire ones?
Oh, you're recording right now?
I'm recording right now. Isn't that great? Yeah. Oh, man. Yeah. Superman that hoe has nothing to do with like using the garden implement like a boss, right? Get after that dirt like Superman. Okay?
Pretty bad, right?
All right, we're done. We're done with this section. Everyone good?
Yes.
Everyone good?
We have 3 minutes.
All right, so we are going to call it quits right there. Tomorrow we are going to start the next section, which is proofs in earnest. We're actually going to start proving things, okay? So make sure you're working on your worksheet and make sure you're showing up and representing at these school functions.